Good morning, Year 3. Today's lesson we're going to be looking at recognizing and describing the properties of different 3D shapes. Let's get started with our discover. Okay, so here we've got the question. It says, how can Ambika find out if her gift is a cube? And part B says, Ambika then describes the faces of her gift. Is it a cube? So have a think, what do you know about cubes? What is special about them and what do all cubes have? Think about the faces, how many of them there are, the shape of them. And then have a go at describing that so that Ambika will know whether her present is a cube or not. Then have a go at looking at using this little picture here of Ambika's present. It's got some measurements on it to help you. So it's 25 centimeters tall, 20 centimeters wide, and 22 centimeters long. Is that a cube? Pause the video now and have a go at that, working that out by yourself, and then come back to the video when you're ready for some answers. Okay, so part A asks us how she would know if it's a cube or not. A cube is a special type of cuboid where all of the edges are the same length and each face is a square. So it's a bit like a dice. Every single face is exactly the same size and each face is a square. That means that all the edges are the same length. If one of those faces was a rectangle or slightly longer than the others, then it would just be a cuboid and not a cube. So Ambika can measure all the sides of her gift to find out if it's a cube. And she has done here, as I said before, we've got 25 centimeters tall, 20 centimeters long, and 22 centimeters deep. If we look at each of those faces, they are not squares, they are actually slightly rectangular. This side is slightly longer than this side. It's the same for each of them. None of those faces are square. For this shape to be a cube, all of the faces must be squares. However, because they are not squares, her gift is not a cube. It is a cuboid because there are some rectangular faces on the shape. Let's move on to a think together problem. Describe the faces of Zach's gift. How long are the sides of each one? So this shape, you can see three faces, the one on the front here, at the top and the side, but there are more than three faces on the shape. I'd like you to have a think if you can spot any of the faces which would be the same. Then have a go at naming this shape as well. Pause the video to have a go at writing down some of your ideas and your answers, and then come back to the video when you're ready. Okay, so this shape is a cuboid. I know it's a cuboid because it will have 6 faces, 1, 2, 3, 4 on the bottom, 5 off the side here, and 6 at the back. These faces at the front are rectangular, 24 centimeters long and 12 centimeters tall. This face on the end here, which is exactly the same as the one that would be on the other end, this is a square face, 12 centimeters wide and 12 centimeters tall. However, just because this shape has 2 square faces, it does not mean that it is a cube. All of the faces must be square in order for it to be a cube. The face at the top of the present here will be exactly the same as the one on the front, 24 centimeters long and 12 centimeters wide. And in fact, these ones all the way around, the 4 faces that go around here, the middle, are all the same, 12 centimeters by 24 centimeters, which makes them rectangular. Because this shape has matching faces on either end, they are the same. If I slice this shape down the middle, then I would have the exact same face appearing in the middle too, and on the end of each of the shapes. This makes it a prism. It doesn't matter where I cut along the shape. I could cut it here, or I could cut it straight down. I could even cut it across the middle here. If I slice that shape into more parts, because the faces on either end are the same, it's called a prism. You can have other prisms, like for example triangular based prisms, or a cylinder is a circular prism, because you can slice those shapes and you would still have the same face on either end. A shape like a cone is not a prism, because if I slice that down the middle, I would have a different size or a different shaped face to any that exist currently on the shape. Question 2. What is the shape of this tent? Count the number of faces, vertices, and edges. So we've talked a little bit about faces already. A face is a flat side of a 3D shape. Vertices you will have talked about when you were in year 2. A vertex is the name for a corner on a 3D shape where 2 or more edges join. An edge, again, this should be familiar from year 2, is where two faces of a 3D shape join together. Okay, so this shape here that the tent makes, have a go at naming it first and then count how many faces, vertices and edges that it would have. Pause the video and then come back when you're ready for some answers. Okay, so this tent is the shape, a triangular prism. It is a triangular prism because the space on the end is shaped like a triangle. And it is a prism because it doesn't matter how deep in it goes, if I cut it here, I'd still see that same triangular face in the middle. The face at the other end of the tent, at the back end of the tent, would still be that same triangular shape as well. So there are 5 faces, 1 and 2 triangles on either side, and then 1, 2, 3 rectangles that are the 3 other faces around the middle. So altogether there are 5. The vertices, the bits where the edges join, there are 6 of them. 3 here, 1, 2, 3, and the same at the other end, 1, 2, and then 3 somewhere in the back corner. Finally, edges where 2 of the faces join together, there are 9 of them. 1, 2, 3, 4, and then 5 and 6 at the base there, 7, 8, 9. Okay, so 9 edges altogether. What I have sent you for today's maths lesson as well is some nets of shapes. This is where somebody has printed the faces onto a piece of paper so that they can be folded and joined together to make 3D shapes. I've sent a selection to you. However, there's loads of these available on the internet. If you're struggling to picture these shapes, have a go at using the nets, cut them out, build them up, and use those to help you with your questions. Another challenge that I would like you to have a go at is finding those shapes in objects around your house. For example, my pen pot here is a cylinder. It has got a circular face here, a curved edge around the middle, and then if it was closed off at the end, the space at the other side would also be a circle. I've also got some post-it notes here. They're a little trickier to see. The post-it notes are a cuboid shape because each of the faces is a rectangle, and there are 6 faces, 6, 8, 10, 12 vertices, and 2, 4, 6, 8, 9, 10, and 12 edges to this shape. Okay, see what objects you can find in your house that are different 3D shapes, if you can name them or maybe even sort them. Some of you will now be ready to go into your Green Power Maths books. Today you are working on page 92. In the book there are lots of pictures of shapes, and some of these shapes have little dotted lines through them. That's to represent the edges that you are unable to see on the front of the shape. They would be at the back. So normally you'd have to turn the shape to see those edges. However, they've used dotted lines to show them through the rest of the shape. If you're ready for a challenge, let's go on to this now. So this question says, sort these shapes using the sorting circles. This is also called a Venn diagram. So shapes that need to go into this circle here are prisms. Shapes that go into this circle here have at least one square face. If your shape is a prism and it has at least one square face, they go in this middle portion here where the circles overlap. If the shape is not a prism and it doesn't have any square faces, you need to still put them on the diagram. They go inside the blue box, but not inside any of the circles. Here are the 6 shapes here. We have got this sort of glass pyramid shape. Looks a bit like the Louvre in Paris. There's a tall block of flats here, the bottom section of a slide, a house, a pyramid and a sphere, the ball. Okay, so have a think now, pause the video and decide where they would go on this diagram, and then come back to the video when you're ready for some answers. Okay, so let's start with this pyramid here. It is a square base pyramid. I can tell it's a square base pyramid because it has got a right angle at this corner here. So this will have at least one square face. However, it's not a prism. A prism I must be able to cut it through the middle or through any section of it, and the faces will still be the same size and shape on either end. However, I cannot do this with this shape, so it is not a prism. Next, let's have a go with that block of flats. It is a prism and it does have at least one square face. I can see that the top of this shape here is a square, and I know that the face at the other end will be the same as well. It's a prism because if I cut it through the middle here, we still have the same size square where I've cut it and on the base. Next, that kind of tube. This is a cylinder because it has a circular face at either end and a curved edge all the way around. It is a prism because even if I cut it at this midpoint, I still have a circular face in the middle. The house as well is a prism. However, it does not have at least one square face. I can see that this side of the shape is a lot shorter than this side here, which means that face at the bottom must be a rectangle. This is a pentagonal prism because it has a pentagon-shaped face at either end. So 1, 2, 3, 4, 5 edges on that front face. So it's a pentagonal prism. Next, the sphere, the ball. This isn't a prism because although if I cut it through the middle, I would end up with a circular face on either end. There are no other circular faces on this shape. It is curved all the way around, so it doesn't have any square faces and it doesn't in fact have any flat faces at all. The last one is a triangular based pyramid. I can see that the angle here is less than 90 degrees, so it must be a triangular based pyramid. Again, this means that it is not a prism and it does not have any square faces. Well done if you got your questions right today. Again, don't forget to go and have a look at the nets that I've sent you, and have a go at finding some objects around your house that are the same shape as those nets. In your book today, you are working on page 92. Good luck with your work, and if you've got any questions, please remember to email me. Bye.